In this video, I'll be showing you how to make a game with a basic growing mechanic using C#. We'll be recreating this character controller, and I'll show you how to do that. In terms of the setup for the scene, if you watched the previous video, you'll know how everything is set up. So if you want to see anything about that, you can just watch the previous video. In there, I'll explain about the different tags we use, as well as the layers, and how we set up the player so that it actually scales from its origin. So if you want to see that, you can watch the beginning of the previous video. But for now, let's remove this controller and create a new one. So I'm going to create a C# script, call it our player controller. And I'm going to open that up. Okay, so there's a couple different ways that you can approach this, but how we're going to do it is essentially when the player clicks on the screen and he holds down his left mouse button, we're going to do a raycast from the mouse position into the world, get that vector 3 position, and tell the cube to move to that position. So to begin, we basically want to check for mouse input, so we can start with creating an update function. And inside this update function, we're going to create an if statement, and we're basically checking for if input dot get mouse button. And in this case, we want to not check for get mouse button down or up. We want to see every frame that the player is holding down the mouse. And 0 is your left mouse button, 1 being your your right mouse button, and 2 is your middle mouse button. So in this case, we just want 0 for left mouse button and to check if that button is being held down. So the next thing we want to do is actually start our raycast. So let's begin by creating our array, and we say camera.main, and we're going to use what's called a screen point array. And what this will do is it'll allow us to use our mouse position on the screen, raycast from that into the world, get that vector 3, and then we can store that as our variable. So for this, we wanted to raycast from our input dot mouse position, and then we want to create our hit, and then do the if statement for our raycast. So we can say if our physics dot raycast ray out hit, and then for our distance of the raycast, we want to check what distance we want for that, because as our player base essentially scales, the camera moves further and further away. So we want to make sure that we account for that distance. So I think in my case 500 should be fine, but depending on how your game is set up, you might use a different value for that. And then for the layer mask, we did mark our floor as the floor layer, so we can use that to basically just raycast to that one layer. But before we do that, we actually need to create a variable for it. So I'm just going to create a private layer mask, and we can call that our mask. And then we just need to tell it what that mask actually is. So in my wake function, I'm going to assign this variable and say that we want this to be our layer mask dot get mask, and it's going to be floor. Okay, so now we can put that mask in here. There we go. And now we basically need to tell it to store this vector 3 to a certain variable that we can use. So I'm going to create a new variable. That's going to be a vector 3, so private vector 3, and we can call that our click location. There we go. And now I can use that variable. There we go. Now I can use that variable, and we're basically going to say that whatever we hit that vector 3 is what this variable is. Let's save that. So now that we actually have that variable for our click location, we want to get the player to move to that point. So in order to do that, we're going to create a fixed update, and inside this we basically want to approach it in a certain way. We want to look at our current position and look at our clicked position, use those two vector 3s and compare the distance between them. And then if the distance is smaller than a certain threshold, bigger than a certain threshold, the player should move to that position. Using a threshold like that just allows it to have to do a lot less calculations when reaching that point, because it sort of stops checking for the distance between them after a certain part. So to do that, we're going to create an if statement, and we're going to use vector3 dot distance. There we go. And we basically want to check our current transform position and compare that to our click location. And we want to see when that is actually greater than or equal to a certain variable. So now we can create our threshold for that. So to do that, I'm going to create a private float, and I'm going to call that our stop distance, because it's essentially going to tell it when to stop. And I just want to make this serializable so I can actually edit it in the editor. There we go. And so now I can use that and put it in here. So this will only happen if the distance between the two is greater than the stop distance. Okay. And so what we want to do in here is actually move it. So we can say in this our transform.position is a new vector3 dot, and we can use move towards. And we want to tell it to move from its current transform position to the new location. And now we can add a variable for our speed, for how fast we want it to move to that location. So can basically duplicate this and name this our move speed, and then we can use that as our speed variable. Okay, and because we are in the fixed update, we just need to times this by time dot delta time, or actually in this case fixed delta time. There we go. And now we can test this. We can go back to the editor. We can assign the script to our player base, and now we can add our values. For this, depends on how you've got your game set up, but in my case, I think 0.05 should be fine for our stopping distance, and for the move speed, I'm just going to set it to 4. And now we can actually test this, and the player should follow to the position when we hold down the left mouse button. So I click and hold, and the cube moves to wherever the mouse is. The next thing now is to actually see when we let the mouse go, the player still moves a little bit to where that last position was, and we sort of want him to stop moving as soon as we let the mouse button go. So that's pretty simple. So to do that, we're just going to go in our update where we check for the button. We're going to say if input.get mouse button up, there we go, and again left mouse button. If the player lets go of the left mouse button, we just want our click location, so in other words our target, to be whatever the current position is. There we go. Now we can test that. Okay. And now the player moves around, and when we let go of the mouse button, the player stops moving. Awesome. Okay, so the next thing we want to do is actually have the player shrink or scale up depending on which orbit picks up. So let's get into that. So we can go back to our code, and we basically want to do a similar thing to how we did our position movement, where we have our current scale and a target scale, and we want to get the player to scale to that new scale. So let's create a variable for that, and we can create a new private vector3. We can call this our target scale, and we just want to make sure that at the start of the scene this target scale is set to whatever the current scale is. That way the player won't try and scale to a default value. It'll always start at whatever scale it is set to be. So let's create a start, and in this just say that our target scale is our current transform dot local scale. There we go. Okay. Then the next thing we want to do is actually check for when we do enter those triggers of the different spheres. So I'm going to add a new on trigger enter, and we're just going to compare the tags of the objects we're triggering. So I'm going to add a if other dot compare tag, and we're looking in the first case for our grow orb. Okay, so the way I want this to work is to basically, when the player picks up this orb, I want the orb to disappear, so I'm just going to destroy it. In this case, you can obviously use object pooling, but for now destroying it is fine. And we just want to destroy our other.game object. And then after that, we essentially want to set what our new target scale is. So in order to actually tell it what that's going to be, we want to be able to have control over how much our object scales every time we pick something up. So to do that, we're going to create a new vector3. Just duplicate that, and we're going to call this our scale factor. Okay, and I want to be able to edit this in the editor, so just make this serializable. Okay, so now we can tell it that whenever we pick up a new orb, we want our target scale to be whatever our current scale was, plus whatever our new scale factor is. That way you can have control of it, and it will consistently scale up or down based on your scale factor. Okay, the last thing I want to do for this is every time something scales up, in my case, I want the scale to get a bit bigger so that the effect of the scale sort of increases as the player picks up more orbs. Depending on how you've got your game set up, you'll probably do this a bit differently, but in my case this will work fine. So I'm going to set that scale factor to be whatever it was times I think 1.2. Okay. So yeah, that'll make it sort of scale up a little bit more every time that it picks up a new orb. So for the shrinking orbs, this is basically the exact same thing we're going to do. So we can just duplicate this whole if statement and say that if we are colliding with our shrink orb, do the following. So again, we want to destroy our orb that we picked up, but instead of adding our scale factor to our target scale, we want to subtract that. And the same with the scale factor increase. We want to, instead of multiplying it, we want to just divide it by the same value. Okay, so now we actually are setting our target scales, but we haven't told it yet to do anything with that target scale. So to do that, I'm going to go into our fixed update and do a very similar thing to how we approached the movement. So I'm going to say if our vector3.distance, and we're going to compare whatever our current scale is. So transform.local scale, and we are comparing it to our target scale. And we're basically saying if this is greater than a certain value. And again, we want to create a threshold for this. So I'm going to go up and create a new vector for this, and or at least it's actually going to be a float, not a vector3, so we can just make that a float, and this is going to be our scale threshold. Okay, also serializable because we do want to be able to edit that, and what we're basically going to say is that distance greater than our scale threshold. If it is, scale it to its new target scale. If it's not, stay as it is. Okay, so now to do the actual scaling, we're going to tell it that we want the transform dot local scale, and in this case I'm going to use a lerp function because it's going to look a lot nicer to have it smoothly scale from its current size to the new size instead of just snapping to the new size. Also visually it'll make a lot more sense. So I'm going to say vector3 dot lerp, and we want to lerp from our current scale, so transform dot local scale, and we want to scale to our target scale, and again we want a value here that we can control to tell it how fast we want it to scale to that new scale. So we can create a new float variable and call this our scale speed. There we go. And now just say we want it to lerp from its current scale to the new scale at the speed of our scale speed, and again just times it by time dot fixed delta time. There we go. Okay, and I think that should do it. Now we can go ahead and go back to our scene and just wait for it to recompile. And we just want to actually put in the new values onto our script. So for our scale factor, I think for this I'll use 0.2. Again, you can make this a float instead of a vector3 if you want, and then just assign it to the different axes. Using a vector3 is nice because you can have it scale differently in different directions, so you can have it just scale sort of wider or longer, or you can just make it scale upwards, so it depends on how you want your stuff to be set up. But I think that's fine. For my threshold for the scaling, I want it to be pretty accurate, so 0.01, and for the scale speed I'll just set it to 2. Awesome. Let's save that. Okay, so now when we pick up a blue orb, the character should scale up. When we pick up a red orb, this character should scale down. So there we go, picked up the blue orbs and the character scales up, and then when we pick up the red orbs, opposite happens and the character scales down. So depending on how you want it, you can mess around with this and create a whole scoring system or enemies or however you want to set it up, but this is the basics of getting this growing mechanic to work. Yeah, there we go. It is useful to have something in the scene to reference to know that you're actually scaling up or down. That's why the particles are there, just to make it a bit easier to see whether or not we are actually scaling up or down. But that's about it for the growing mechanic, and you can use this to basically make however you want to set up your game with a growing mechanic.